Let's see here. So hi, welcome to my presentation on developing distributed autonomy at Pluralsight. My name is Jennifer Carlston. I'm a software architect, software system architect at Pluralsight. When people ask what I do for a living, I usually say I help teams write software that help other people write software. This is a new speech. Please let me know what you think afterward. I'll also be teaching a hands-on lab tomorrow around lean process modeling with Indu. Today I'll speak about the principles, practices, and use cases at Pluralsight that could help you develop a distributed event-driven system. Hopefully by the end, you'll have a good idea of what it's like to develop software at my organization, be able to break down development processes in an event-driven way, and how that ties into business outcomes. For context, I want you to have some insight into my personal viewpoint. Where I've come from affects how I see the world. Throughout my career, I've worked with people to create tools that process massive amounts of information. I started out testing telco systems and integrating phone and IVR systems. I moved into making stock market charting software and technical analysis education at a company that was bought by Reuters, among other things. Basically, I've written data engines for systems all over the world. The principles I learned growing up actually shape a lot of what I perceive, so I wanted to explain a bit about that. I grew up in what you'd probably consider the Wild West, Salt Lake City and Grand Junction, Utah. There were a lot of teachers in my family, although my dad was a bit of an adrenaline junkie and liked to race cars and be outdoors. My grandparents were really dynamic people. Among other many amazing things they did, they ran a sports school for children on their small farm. It was a little bit like the summer farm tradition. They focused on teaching physical and personal development. I learned to swim, play a lot of different kinds of sports, use a scientific process on the farm, and I learned how to ride horses. My horse's name was actually Big Red. People in their home were noisy, exciting, focused on learning and helping others. Our mentors encouraged us to succeed. When we played, we collaborated, and we cheered each other on. While I lived there, I learned things like incremental changes in habits lead to lasting and better health, that autonomy allows us to experiment and learn, and understanding our responsibilities is essential for that autonomy. Ultimately, they taught me that an unswerving quest for truth can give us the chance to understand and mold our reality. When I walked into Pluralsight, it felt familiar. It felt the type of focus, the type of excitement, the way people acted reminded me of the farm. People at Pluralsight are happy, they get things done, they're open to questions and new ideas. It's not a very political place. I really like that. They're open to changing their minds and sharing evidence, and they accept personal responsibility. We do things a little differently and in an exciting way that really attracted me to start working with them. And their mission is to democratize technology skills, which is something I actually can personally get behind. At Pluralsight, people walk around saying a lot of interesting things. Here are a few context-free quotes. What's amazing is that we have a lot of fun, and we still managed to deploy 10,000 times last year. We're getting better at what we do. We add more features, more value, more quickly as we grow our skills. And our architecture grows with us. When I ask people at work what you at this conference should know about Pluralsight, this is what some of them said. I'd like to call a couple of these out in particular because they apply to our social and technical architecture. Best realization of lean agile in practice, and a decoupled architecture is essential to have continuous delivery with multiple teams. Let's dive into those a little bit. Lean thinking and a decoupled event-driven architecture is what allowed us to deploy 10,000 times last year. We're able to grow incrementally and add new nodes easily. We consider a bounded context a node or an atomic unit in our system graph. As our system has grown, it's become more and more distributed and diverse. Each BC is an independently deployable unit owned by a single team. Lean principles affect how we work together every day. Our teams are autonomously responsible for a portion of our product, a certain repo of code, workflow, scheduling, and deploys. We modeled our architecture after Conway's Game of Life for local simplicity and global complexity. BCs, coupled with the team, are our independent agent actors within the system. In the Game of Life, evolution is determined by the initial state. I see that as the principles that we code by. When the original system architects at Pluralsight set out to deconstruct the monolith, we had one driving edict: don't block me. This is a principle of Lean. Don't block people from learning. Don't block people from events streaming in. Don't block users from getting to the features. We built an architecture that could scale and evolve to deliver value to the teams, because teams were responsible for delivering value to the customer. The teams interface with the customers to find out what they need as they move through a BC. Our teams understand what customers want. We conduct interviews, set up infrastructure, create experiments, write tests, develop code, and push that all-important deploy button. Teams hold and build the context. Calling back to distributed autonomy, our teams are distributed and responsible. We act autonomously in most situations, and team and data flow are our lifeblood. In 2012, a deal was made to offer a private library of ours to all MSDN subscribers. Our servers ran on a set of stacks and racks, at the time with maybe 15 developers. So imagine large conference, Bill Gates gets up at the Build conference and announces to all the people there that they now have Pluralsight access. And at this giant conference, people hopped on their phones to redeem through our hosted monolith. You might guess what happened. The amount of load took it down. It's a great problem to have, but also, not. So the developers scrambled, and a team quickly peeled off the offer redemption code into the cloud. They launched a new website and routed a request queue into the monolith. The queue throttled the traffic to a rate the monolith could handle, and our first BC was born. We implemented a rabbit cluster to continue this pattern of decoupled event-driven architecture and slowly move vertical slices of our monolith into the cloud as independent and autonomous experiences. Conway proved architecture as well as culture is an emergent property of our principles and beliefs, the few simple rules that govern behavior. Don't block me was our first principle, but we defined others to help us function and further refine that. This feeds the initial state of our actor agents. Our principles define who we are and how we work together. At Pluralsight, we'd have 10 of them, and you can search for the rest of them on our tech blog. The principles are similar to those I had at the sports school growing up. We all worked together as a team. We competed with ourselves more than anything, alongside each other, and we had each other's back. Our leaders played alongside us. They showed us how the games worked. They demonstrated and gave us guidelines, and then we tried as hard as we could. We iterated on our skills. We tested our abilities. We found the simplest path to success, and we got better with practice over time. We kept records and logs of our efforts and could see how we improved. Teachers would coordinate as we moved around the field, depending on what was happening. If one field was flooded, teachers would coordinate and adjust. The teachers in the classes were autonomous, and they collaborated to bring the entire school together to learn certain techniques and play large games. At Pluralsight, we have agile and lean practices tied to our 10 principles. Things like BCs can be reprogrammed in a few weeks. They're independently deployable by a single team. They must pass all tests, and teams use our implementation checklist before deploying. They're scanned and tested regularly in runtime and in build time for security holes and good practices. We encourage teams to think about events and language first and implement a 10x design requirement for all systems. Testing patterns like red-green refactor, canary releases, code katas, bug bounties Hack days and fire drills are encouraged. We use skateboard experiments, A/B tests, and feature flags to understand behaviors. All of this, again, feeds into our ability to work autonomously in a distributed environment, in a bit like Conway's Game of Life. So, in order to be responsible, autonomous, and distributed, we need to be able to act as a unit. The principles dictate that every person necessary to make decisions about delivery is on a single team. We've implemented practices and structure to make that possible. Our RAPID framework implements decision delegation. So not all decisions are equal, and we have a framework that helps teams know when to consult with leadership and experts or other teams. Generally, it's when a decision affects people outside their bounded context. For example, when they change their schema, we have a versioning process that's enforced and agreed upon. And if a team or leadership wants to change how or when other teams work with them, they consult our RAPID framework. Teams at Pluralsight are anywhere from 3 to 10 members. We prefer that they mob and pair, which I'll talk about in a moment. We require 2 pairs of eyes on all code. Teams use expert advisors like architects, DevOps, and principals to dive deeper into technologies and practices. Business unit leadership helps guide prioritization and high-level strategy. As teams work together, they limit their work in progress to what's most important and focus on a single piece flow. So at the sports school, older children would often mentor younger children in the same groups. Children would pair and work together as a team to figure out how to improve. Even when it was climbing the rope, we'd encourage and give tips and tricks. Younger children would often think of new ways to do things and ask interesting questions. We all learned from each other. Mobbing on code is a lot like this. It's faster, it removes blocks, we're able to share more easily and to deepen our knowledge more quickly. We create a continuous stream of team wisdom when we mob. It eliminates siloing and gives us a better work-life balance. All this leads to greater happiness and more satisfying environments for everyone involved. I really like mobbing. It's awesome. Designers and product managers are encouraged to take part in mobs as well. So we've got everyone learning how to code and how the code's structured. The practices around it are in the morning, generally teams will get together, they'll decide on what they're going to focus on, figure out the tasks that they're going to complete, and then they'll rotate a driver and navigator control in 15 to 20-minute intervals. After every round, teams hold a brief retro to discuss improvements to the process. They then split off on smaller tasks, maybe around lunchtime, and come again together to deploy. Teams are generally deploying once a day, or it could be more than that. And they're broken up, the tasks are broken up into small enough testable chunks to make this possible. So when I mob with my team, it's generally done remotely. We log into video chat and VS Code to share control. We rotate assignment with the navigator and driver. We use our mob timer, which is free and open source on our site. There's a link up there somewhere down at the bottom. We make API call. We reflect on our process continuously. The architecture team, we're just constantly going back and forth and discussing what we're going to do, and then someone's coding while we're doing that, and we're calling them out or telling them what's going on, what we think they should be doing. So pictured up here are some charts that we created for our intranet site. We made some API calls into our platform tools to grab information about publishers and subscribers between our bounded contexts. We munged all the data, generated a data structure, and formatted a few different charts like these. They show relative connection amounts, directionality, and relative counts across our business units and our bounded contexts. There were so many bounded contexts that I chose to show you the business unit breakdown instead. So reflexivity means self-reference, your ability to self-examine, to reflect back on yourself. This is our architecture team at an off-site late last year. As architects, we're responsible for the stability of the system. That's not actually all of us. I think there's 7 6.5. We designed our system to grow and quickly deploy. And at offsites like this, we set objectives and key results. We event storm about problems we might meet with other teams, other leaders. That helps us shift our perspective when we're not in the office. We're working remotely, and it helps us get out of our normal mindset. Last year, again, we deployed 10,000 times, and that means a PXT independently researched, developed, tested, and hit that deploy button to deliver unique value to our customers. We're able to move rapidly, we iterate into the changing landscape, and we're getting faster every day. So this is the tech radar that we have at our office. It's a system that the architects developed that allows teams to consult and be aware of what technology is in use at Pluralsight. Our reasoning is that we want to empower the teams and give them a visibility to observe the system and make informed choices. Teams can now consult with other teams and ask questions about their tech usage, and this helps them learn and keep an eye on system trends. There's actually a lot more information that's displayed. I just couldn't show it all to you. In the future, we probably want to add things like API calls into the team repos to scan the code and the infrastructure, and then integrate the radar into Slack, Git, and our new Flow product. All of this really illustrates this quote from Alberto. Learning is how we apply the rules in the game of life that is our distributed system. The process allows us to adapt and build a better distributed architecture. We can adjust our responsibilities around our autonomy. Our teams have to be able to learn from the events that flow from and between the BCs and the automated agents of our system. I'll give some examples that explains this chart a little more. Hopefully you've seen something like it before. In an event-driven architecture, the learning process occurs as information is distributed throughout our system. An event happens, we observe it, associate information, meaning internally, relate it to other events around it, synthesize the related events into some kind of trend, model, or pattern, and integrate that model into our systems. What happens as an event moves through the distributed architecture like ours, it is similar to an event propagating in a stock market exchange. So we'll draw some general parallels from my previous experience there, as well as some examples from Pluralsight. So at Pluralsight, we begin to observe our customers through our interview and directed discovery process. I'll speak about that a little bit in the workshop that I'm doing with Indu tomorrow. Teams ask questions like, are we meeting customers in their moment of need? And what are people experiencing inside our bounded contexts? This leads to generating and consuming events. There are many different types of events in a bounded context and within a system. I've categorized them into 4 relatively distinct groups. I'd love to talk to you if you think these are at all controversial. Entities are the objects, the nouns in our system that are owned by a BC. They're items that have a unique ID that might get shared across bounded contexts. Entity snapshot events are compacted states that might get shared to multiple BCs and to our data teams for modeling. So that's the complete data set of a certain state. Entity changes inform downstream processes of the state changes. Obviously, probably are pretty familiar with this at the EventSourcing conference, but they can be used, to recreate the state of the object. You can create the snapshot from the entity change. Telemetry events are analytic and informational. They might include things like logs, debug, error messages, infrastructure status, and alerts. They help us understand how our products are performing. State can't be determined from these, but they do help us analyze application performance over a longer and broader term. And then there are behavioral events, which help us understand our user and the usage of our product. They might include clickstream events and help us analyze behavior. They're more similar to telemetry and then change notifications because they cannot be used to recreate state. but they still might be linked to state changes. So, as we observe something, things happen, we know something happened, commands run inside the domain, and an event is generated. Imagine a stock market. It's noisy, lots of things are happening, people are buying and selling, trading, it's all recorded in the exchange. The marketplace is the data stream. The data stream weaves through all sorts of different companies, issuing updates, formatting, cleaning, disseminating to ticker plants, institutions, brokers, traders. The exchange acts as the event store. At Pluralsight, a user clicks a link and loads a page. They fill out a form. The application runs and generates events. The database makes calls, etc. A command called redeem offer code runs. A ton of behavioral and telemetry data is generated. The event offer code redeemed is generated as well. So we take in data as the world around us changes. Events are part of our business domain. This is the beginning of the technical anatomy of our bounded contexts. BCs hold the logic that generate the events. Let's say the yellow dot up there represents our event. We begin to ask questions like who, what, when, where, and associate meaning with it. We begin to understand its internal properties, its shape, and its measure. We associate meaning, information, with the observed event data. We place it in context inside of a grid of activity. The stock market, we associate properties common to the type of event. The exchange collects information from a lot of disparate sources, standardizes it, and issues it out. Our exchange can answer who bought what, when, and at what price. Pluralsight, the offer code redeemed event, has properties that relate to other things in the domain of the BC. It's associated with a user inside the BC's data store. It's associated with click streams and form info, telemetry and system information. The associated objects and the properties might be added to the external schema of the offer code redemption BC. Bounded context, you probably know all that. As we observe, we begin to ask questions about what happened. We begin to understand its shape and measure. We associate meaning, information with the observed event data. We give it context. So, events have information associated with them. If we choose to implement an event standard, they might have headers that are common to all events. Things like timestamps, publisher information, originating event key. Perhaps they're added to an event registry or a schema registry. They might be given an ID and a label that might be useful in categorizing. Your organization might use an envelope to standardize on the metadata on the header. This envelope could help you make more intelligent transactional event tracing possible. Events also have a body, which contains properties of that specific event. Body properties should include a primary key, the related foreign or composite keys, and all externally available UUIDs involved. Body properties should include all the API input parameters as well. When sharing the state of an event, you might need to include other information that you're not the source of truth on, depending on coupling and causal relationships that you're constrained by between the specific publishers and consumers of the events. So, as we associate data inside our BC, we need somewhere to store it and develop ways of controlling, managing, and reflecting on the data generated in that business domain. Once we understand what we're delivering on, we need to be able to measure how efficiently we can deliver. We need to be able to relate that information to other events, bounded contexts, and systems. We ask questions like, how quickly are we able to deliver value to our customers? How many times were we able to deliver value over a given time? And how much is too much eventual consistency in a given situation? So we can now ask questions like, how are customers experiencing the BCs adjoining us? And that leads us to relating events. There are causal and temporal relationships with other BCs and other events in our system. Our distributed system, with its event-driven architecture, can help us to relate context. We start to find these related events. We collect more data to answer questions about it. It might be linked in time by any other number of variants. At Pluralsight, we use event choreography as opposed to orchestration to allow for more system scalability. Choreography encourages a looser coupling between systems. It establishes a pattern and a standard that allows people to work faster, responsibly, with bulkhead autonomy. Choreography allows us to decouple events from the source of truth and to act asynchronously. Having an event broker in place allows us to throttle and control the flow of traffic as necessary through our system. It helps us identify and create a natural place to break our experiences up as well. A BC is better able to control the flow of user traffic into our site by breaking it out into its own experience and placing a gate between it and others. You might even think of a BC in this model as a complex circuit of social and technical interactions. So we currently have 3 different ways of sharing information between our bounded contexts. We can use all of these methods to help us maintain availability, redundancy, and stability in the in-between spaces of our actor agents. We're loosely coupled and still maintain high cohesion using these methods of sharing and synchronizing. We've written a standard API connection interface into Kafka. We have platform messaging tools integrating standards into a Rabbit exchange. And we have standards around APIs for self-healing and once-off HTTP requests into our system. They're used in a number of different ways. DVS gives us a secondary source of truth for consuming events and the entity state. Rabbit lets us share them in a fan-out system. And self-healing allows synchronous and temporal calls when it's necessary to meet customer needs across the bounded contexts. So RBCs need to be able to take data in from other sources. We add security, reports, dashboards, CLIs, as well as publishers and listeners to connect to the Rabbit cluster, the system-level event store, and the self-healing APIs. We implement an anti-corruption layer between the data store, the public schema, and the domain model. So we've got a connection to the relevant BCs, and we need to share between them. We take what we've learned and we find other similar events. We draw some correlations and begin to understand how the events from the other BCs are related. We begin to see a trend. Information begins to become knowledge. We see a relationship between the data points we've collected that we didn't expect. We now understand how something happened. And we can ask questions like, are there any behavioral patterns that are common among our customers across the BCs? On the stock market, a day trader listens to a stream and relates trades inside of it. They group other events together based on the associations made, by what they own, and by what previous trades were. They might see upward, lateral, and downward trends in an asset class or an index group of entities that they created. So at Pluralsight, we now know how data gets into the offer code redemption system. Since we join the offer code redeemed event with the user, we can see what else they're doing on our site. The events gets published into a fan-out exchange. Another BC, let's say plans, picks it up and groups the event and user information with plan information. The teams notice that certain users are behaving differently depending on the plan. We relate the information to other knowledge we have about the system. We see a relationship between the data points we've collected and find a trend. So we notice that the events, all of these events that we've related together, are like another series of events we've seen somewhere else. We've synthesized the data and found a pattern. In synthesizing the pattern, we begin to understand why. In the stock market, the day trader begins to get wise to some of the fundamental and technical market. Has anyone ever done technical analysis before? No. Okay. So you might have heard some of the wild names. There are a lot of wild names for the patterns that technical analysts come up with and the modeling tools. So there are things like Andrew's pitchfork, head and shoulders, random forest, dead cat bounce. I used to hang with people that modeled these for a living. There are a ton of them. Patterns and models can help you identify trends sooner and make predictions on the likelihoods in the future. So users are authenticated and authorized and passed into the Pluralsight homepage. The team notices that within certain plans, the user experience is less than ideal for some of our auto-provisioned SSO customers logging into the site. We determine from a certain pattern of events that the home page doesn't have all the data it needs to build the best experience until after the identity BC has redirected the user to the user's home page. This can happen with eventual consistency. CAP theorem still applies. So users that have a business account might see a free user account page rather than a custom plan page for a few moments as the system resolves its eventual consistency. The user's homepage calls an API to get the data, but the event that notifies the homepage team about a user's plan information hasn't arrived yet. The team sees a trend and sees that this is happening more and more as we grow and shift our business strategy. They link it to a certain type of behavior with data from subscriptions as well. Users logged in for the first time through different means behave differently. And more importantly, their data behaves differently. They may need to be redirected to a different experience within our site after they've logged in. So we've found a pattern underlying the event and the behavior. We're able to identify, recreate, and predict what might happen and what needs to be done in the future. We synthesize the pattern and begin to understand why. We build wisdom around the domain we're working with, and eventually might create a new BC, a new experience. Synthesizing gave us the tools that we need to build something new. Integrations are how we grow. We strategize, we innovate, we iterate based on what we've learned and what patterns we've identified. This is a process that we go through every day in different ways. In the stock market, let's say the day trader runs a scan, they build a model that helps them buy another stock based on the scanned match to their pattern. They make money because they used a model that was data-driven and research-based, backed by the events of the system. So at Pluralsight, all the data we've collected helped the identity BC realize that some users needed a different experience. We found a need through this process that will allow us to improve the user experience on the site. And we're going to create an experiment going forward from here. After discussing with the teams, we may ask the identity team to generate a new event like user plan provision requested, or we might create an event on partial user payload information that's available a bit earlier. We've started discussions around the logic that may be necessary for users moving between identity and the home page. From there, we can decide what we want to build, whether it's a new user experience or just change the current experience around a user that's not been fully provisioned in our system. So these are examples of how and why event-driven architectures work. And they help us maintain distributed autonomy. It's a better model for reflecting our reality. Events are what build our foundation for creating distributed systems. You're able to build your context based on real observations, replay them, and innovate repeatedly across a wide area of business and within the team experience. So there's a lot of variance in how teams might implement code in a BC at Pluralsight. Currently, we're all hosted on AWS, but we're looking to expand into a Polynembus infrastructure. So Polynembus means implementing solutions utilizing the strengths and tools within each cloud provider. That doesn't mean we're replicating everything we're doing across all three. We're just using what we think is best in each one. This requires us to rethink our security and data sharing models to a rather large extent and puts a lot of pressure on our DevOps, but we see value there for our customers and our potential acquisitions. So our first task in creating a BC is understanding its ubiquitous language. Then we dive into the user experience it's building and the customer need it's answering. As we begin to understand all of that, an engineering language needs to be chosen. So we encourage teams to develop based on the strengths of the language. Its level and as well as its level of adoption in our tech radar. And then also how well it might work with the adjoining BCs inside the Rapid framework. Sometimes that can help when they're speaking the same code language. Teams are generally autonomous, But if there are concerns because of the choices that they're making, say multi-threading or math crunching abilities of the language, we may start discussions with the teams to make more specific agreements. Much like when I was at the sports school, we standardized on the rules of play between the groups of students. We all have integration standards, but outside of that, we're free to get to the goal any way we can. We might come up with different plays or patterns that help us get there together as a team, and each team might have different ones. We believe that a certain level of diversity in our complex system is the ability to adapt, gives us the ability to adapt and respond to the market in more interesting ways. The tech radar helps us manage how much diversity we have in the system. So the system being designed for diversity this way has some good side effects from our point of view. We can implement the right tools for the job. We have a variety of types of infrastructure and workflow pipelines. We're able to learn from what works and implement standard recommendations based on research and experimentation. It does create a very varied workload for our team members, but it also allows them to dive deep in areas that they're interested in. So I'll tell you a little story about an acquisition that we had a few years ago. Our board came to us and said, we want to buy this company. How long is it going to take? And the architecture looked at it and was like, we think it'll take about 2 months. The board was really surprised. They were like, we've never heard of anything like that. It should take you 6 months if we're acquiring an entirely new company. We're like, no, I think we can do it. And 2 months go by, we delivered because of the way our architecture is designed. We transferred them into our VPC, got them connected to our domain and our clusters, and rerouted the domain for the most part. There were a few things to clear up here and there, but it was a pretty quick process. The newly acquired company didn't have to rewrite their code base or their infrastructure to any great extent, and they could integrate their product design on demand. So new BCs can be added or split into nodes within our system. We actually prefer splits. We take data from a number of different experiences, and either it grows to a point where one team can't manage all of it, or we combine the data and research into something new. We currently have a platform design team that maintains our design system and navigation to unify the look and feel. Some business units are also implementing standards to unify persona experiences across our organization. I'd love to learn more about what others do to manage integrations and divide their work and code. I'd love to hear from you after this talk if you're willing to talk to me. We've found patterns that work to help us create new BCs, and event-driven architectures drive that process of distribution to build loosely coupled, highly cohesive systems. So I'll tell you a story about a recent acquisition as well. Last year, we completely reorganized our engineering department. So there was a lot of flux and some change. And because of that, we learned a lot, and I'm here to tell you about it. While we were shifting, we also acquired a new company and 8 new teams that were already established teams. All of this was a huge shift in our landscape and in the nodes of our system. In the last month, the newly acquired Git Prime product has been converted and integrated as a new product at Pluralsight called Flow. It's to great success and fanfare overall. Git Prime provides engineering intelligence for dev teams in order to reflect on things like workflows, code quality, developer load. From my standpoint, this is what I saw happen. Our entire engineering department was reorganized. Business units were formed with the intention of unifying strategic goals among certain types of teams that were aligned with certain personas. That, in and of itself, was a huge architectural shift and social shift. The company then, a few months into this, purchased Git Prime and wanted to make it a part of its product offerings, of our product offerings. All of the teams involved met with some of the key Git Prime personnel, learned about the product, and worked with the team to create a way of demoing it to our current customers. At the end of August, an entirely new product was announced by our leadership called Flow, and a deadline was given to launch it in mid-January. So we met at an offsite in September about security and user handling. We talked about how we were going to unify the user access and get their users into our system. We talked about the differences between the SSO payloads and how we were going to do authentication, authorization between the systems. We wanted to manage the users uniformly, things like that. There were a number of user provisioning differences, and we finished the offsite with an event storm on some possible solutions. We worked to move GitPrime's cloud into our VPC, connected them to our event clusters to share data back and forth, and began onboarding and training the teams with our principles and practices as much as possible in the time that we had. This is all while our teams are shifting, growing, and the organization structure has fundamentally changed. Teams discussed how to add the new product into the existing Pluralsight system, and then worked to understand what needed to be done using event storming and other discovery process techniques that we use in-house. In that process, we built and associated information with terms like product, subscription, plan, user. GitPrime and Pluralsight used similar words with very different associative properties and relational schemas. So we mapped and cleared that up as much as possible up front. As we worked to get the teams on the same page by holding further offsites and meeting to help us communicate closely, we changed the SSO payload to accommodate both the existing and the new products. We noticed GitPrime working efficiently across multiple teams using Git Flow, whereas most of our teams mobbed and worked together using trunk-based development techniques. One issue we noticed with all of that was the amount of waiting time the teams had in getting requests through because of those workflow differences. We worked with our practices department, DevOps, and IT to figure out what needed to happen, how we might work together more closely. We built flowcharts, whiteboarded, and had many discussions and Slack chats. About this time, I was working with ops, legal, and product design to understand the new product offering as well as understand how the reorg was changing the domain. I don't think any of us had a whole lot of bandwidth to reflect and implement the principles and practices fully for the new teams, for the 8 new teams. The teams are in the process of adding an entirely new navigation feature set as well, designing the new Flow product, layout and experience, getting connected to our data exchanges to manage events and requests, and designing the reports in the new product as well. The deadline put a crunch on the work that needed to be done, and the teams ended up focusing more on what to do rather than how to do it over the next few months. It was tighter than we hoped for a number of reasons. During development, a key member of GitPrime died unexpectedly, which was very difficult for everyone, personally as well as professionally. Siloing knowledge is a huge risk factor that mobbing can mitigate. My architecture team does it across 3 time zones, but it gets more difficult the greater the longitudinal difference. I think there was a lot of stress placed on the teams because of all of this. 2 of the GitPrime tech leads left the company during this time, which was a big blow to everyone. We don't like losing good engineers. The stress of trying to merge the cultures at the same time as we were merging the technical and design systems, along with creating an entirely new product and operations all combined into something of a perfect storm. Acquisitions can be difficult to adjust to in the best of cases. Everyone has to learn from one another for it to work. We have to change our paradigms and adjust our mindsets moving forward. We have to understand the current state enough to break down the steps to get to the desired state. I think that the system architecture made it much easier than it could have been. Notably, we were able to get the infrastructures talking in a matter of days, and they were able to use our design system to get the standards on the product experience. As well, GitPrime did not have to rewrite the entire code base to make the new product work within our system. But implementing the existing reports proved difficult because we were changing the background from light to dark, and that affected the visibility of some of the report data. The GitPrime teams really worked incredibly hard to get this done, and they pulled off some amazing feats of engineering in the new product. Ultimately, it ended up being a much bigger ask than initially thought, so soon after our company reorg. In some retro discussions, we agreed that when deadlines are set because of business needs, rather than as a response to how long it will take to do the work, it can create a lot of stress for teams, and we want to do better with that going forward. I'd like us to meet more upfront and build those relationships with new teams, and to build a better and more open dialogue with everyone working together. If I'd had time, I would have liked to dive deeper and help our teams out more. That has been a big challenge for me as an architect with as many teams as we have. I'd love to hear how others manage their personal job priorities and utilization. Teams were empowered to work to make changes, but there was an impedance mismatch between the teams and their practices and principles. They all worked together successfully and delivered by the deadline, but it highlighted the challenges in doing that more clearly for me. More than anything else in my experience, risk and problems occur when people feel under the gun and let principles and practices slide, or they haven't been trained on them fully. I truly believe that if we had slowed down and focused on the underlying principles, the new teams would have felt less stress over that time. Yet the workload deadline made it difficult to focus and weigh the riskier option from a product perspective. Deadline-driven development undermines principles and practices. It's an anti-pattern that sabotages the very reasons and the way we work together. People don't always fully comprehend the risks of breaking those initial system states. Setting a deadline should always be carefully considered. Deadline-driven development is like slicing into the golden goose. You can get away with it if you're careful, but it will weaken the structure of the system, and you'll have technical and social debt to clean up and refactor. It changes the patterns of communication and workflow. It can break that all-important team and data sync, our lifeblood. In the future, we want to work on better acquisition onboarding and remote practices to build more understanding across teams. When we slow down exactly when we feel pressured to speed up, I've learned that we can actually meet our goals more readily. If we communicate terms and train upfront, it gives us the pathways to listen and be heard down the road. Teams work the way they do for lots of reasons, but it's always in response to the environments in which they were grown. Our principles and practices should ultimately create better satisfaction for everyone involved, with the focus being on team health. From here on out, I think we'll learn to better red-green refactor our way into an acquisition MVP. Those principles and practices underpin everything we do, and they're important for us to be able to move quickly. It's definitely a learning process as we develop distributed autonomy responsibly. So, we're currently experimenting with service mesh solutions that'll affect some of our autonomy of our BCs. Hopefully, it will simplify the amount of work that teams have to do getting them set up to handle the inter-service HTTP communication, to handle security, reporting, dashboards, things like that. We'll maintain our AMQP and Kafka buses on the backside. I know there are issues that we might run into moving forward if you've implemented sidecar or service proxies and it's affected your BC architecture. I'd be curious to hear more about your experiences. So some of our biggest and most interesting challenges going forward are around how to create better observability and visibility into our system, our products, and the people from various perspectives. How best to manage our data and our control planes as we build out the service mesh, what security and data propagation will look like in the future across clouds, and improving our coordination between teams and across business units. Part of why I'm here is to see what I can learn from all of you in these areas. We're trying to keep things as asynchronous as much as possible. We've found it to be a good principle for communication across our system. We're working to improve how we integrate new principles and practices with already established teams. And we want to meet and exceed our enterprise client needs by being able to satisfy them in new and unexpected ways. So let's go over the high level again around what happens as a system of events are distributed. When we're trying to learn something about the world, we have to deconstruct it. We observe an event, but what does that mean? We place it in context with itself. We make a decision around what it might mean to us based on our personal experience and current situation. Eventually, we assign meaning. We then make associations between that event and other events that have similar meaning to us. We build predictions based on potential events in the future. From there, we make decisions and integrate them to build our models and our patterns as we move forward. So observe, offer code redeemed, associate with the user ID, relate it to the plans BC and the subscriptions BC, determine a redirect pattern and a user experience to synthesize our learning, and then experiment to build a better user experience and possibly a new BC. Our architecture grows in response to a changing landscape of business and customer need because it's built on our principles. It's distributed and intentionally laid out in such a way to optimize for team autonomy and ease of integration. As we go through the learning process, we experience different states. A day trader might feel comfortable as long as their patterns are reliably predicting, but as soon as they don't, they might find themselves doubtful and confused. It didn't work. Our code might perform as intended within understood thresholds, but when those thresholds change unexpectedly, things start happening. Our infrastructure falls down, our code breaks, our users have a less than ideal experience. We need to refactor. Now we have an opportunity. This is great. We can learn more, relate it to other situations, acquire new skills. If we harness the events, we can create new associations, relate, synthesize, and grow. As we start to understand what caused an event and what biases and assumptions we made that meant our model was incomplete, we learn better and adjust. We're able to deliver more quickly as we get better at this process and when we empower teams to act responsibly on their own. Learning is a process of expanding our perspectives, grown from new events, information, tools, and patterns and wisdom. As teams, we move through this process while we're developing software, because if you recall, software development is a learning process. Working code is the side effect. Working models are the side effect. Automation is a side effect of understanding events well enough to repeat them. Event-driven architectures, our principles and our practices help us learn across a distributed system. So today, we talked about distributed autonomy and how decoupling from run and build dependencies can help us grow, how it shifts the organization and the practices of your team or teams, how the 10 principles of engineering at Pluralsight document that underpin our systems and our culture help us become better at being responsibly autonomous. Our principles affect our ability to learn, to act, and how we play together, our sense of sportsmanship in our system. Don't block me, and lean thinking reduce decision-making bottlenecks. The principles led to practices like mobbing, offsites, and event choreography for sharing information. Mobbing improves cross-functionality and helps with integrating diverse systems and individuals, which led us to some case studies, the learning process, types of events, and how our architecture is organized. All of this impacts our business and some of our current challenges. Domain-driven design works well with a distributed architecture, and our system is proof of that. Event-driven decisions can drive the formation of new bounded contexts in ways you might not have imagined before. Our business is better able to strategize and move when we work with the events using our principles and practices to determine our future. As those needs are surfaced through learning more about them, what the customer needs can actually bubble up and drive us incrementally forward. We believe designing it intentionally from principles like ours can help. Together, we can all learn new skills. We can grow and create better technology based on the states that underpin distributed autonomy. Our architecture, our platform, and our practices can help. Thank you for listening. I'm more than happy to discuss the examples I gave in further detail after this talk. I'd love to get your feedback on the presentation and learn as much as I am able from all of you. So please reach out to me.